Hello everyone, sorry for the delay, thanks for hanging on to the graveyard shift at this Groundswell 2020, appropriately named Death by Chicken Manure on the River Wye, so bear with us on that. So basically the main villain of the piece is phosphorus. I'm Stephen Ware and I'm going to share with you my phosphorus story, then these guys are going to talk about a little trial we've got on the go, which is basically baling chicken manure. I'm going to really rattle on through this, questions at the end. We've got a lot of ground to cover. So this is what a regenerative farm looks 12 years into a project. Basically, lots of agroforestry, still some poultry, a lot less intensive orchards than we used to have. What we aim to do is extensify the business, but I'll talk to you about that in a minute. The Wye catchment is about the fourth longest river in England. It's 4,017 square kilometres, and most significantly, it's in England and Wales. So we've got cross-border issues with all the agencies involved. Very different agriculture in Herefordshire and Wales as well. And the key thing is an SSSI. So our targets for phosphorus, for instance, are a lot lower than a lot of other rivers. So no, we're not making excuses, but just bear that in mind because it might be coming to a catchment near you at any time, the same issues that we're facing on the Wye. So I'm going to start with a brief story of phosphorus which spans 1 billion years. Now the reason I put that up there is, well, you thought lockdown was a murder. Well, try talking to geologists. They deal in billions of years. But the key point here is that phosphorus was the key to unlocking the boring billion, where life stopped. It basically stopped developing. Professor Tim Linton at Exeter University talks about a tipping point, and that's where nature learned to recycle phosphorus 50 times. Now, if you try and recycle phosphorus on my farm 50 times, that would be a miracle. But whatever we've done to screw up our soil and everything, surely the microcosm of geological time that we're dealing with, we can sort it out and resolve it. So don't lose heart. There's hope there for everyone. My phosphorus story started round about 2007. This is a picture of an orchard. We had something quaintly called a sterile strip underneath the trees. And I lived in paranoia of somebody smart coming on my farm and saying, well, why are you trying to grow trees in a sterile strip? You know, it's madness. But about the same time, we had, I started asking questions about soil. And agronomists came through with some soil results. I won't show you the company, but phosphorus indices are 4s, which if 5's the maximum, 4's pretty up there. Comments, MK, MG, status good. With no requirements for additional fertilisers at the moment. Poultry litter inputs are maintaining indices, in particular P in excess of crop requirements, and pH levels are very low and need attention. That started alarm bells ringing in my mind, and I thought, well, I need to understand a bit more about phosphorus. So I started digging around. It's a voracious anion. It's got 3 negative charges. What else has 3 negative charges is our soil, the clay in our soil. So it competes and it can bind up your soil. It can lock it up very, very effectively, particularly in acidic soils, aluminium and iron, and in alkaline soils, if you're unfortunate to have that, perhaps calcareous soils, calcium. So it's very labile. It doesn't gas off. It needs 12 degrees to be reactive. And so basically it's just there and you can't do much about it. Unlike nitrogen, where it will gas off and it's an air diffusion problem, that's not your problem. It can go somewhere else. The more you learn about it, the more difficult it is to deal with. But strangely enough, it does associate with ammonium to make it in an available form, and that's good because there's loads of it in chicken manure. Chicken manure isn't necessarily entirely the villain of the piece either. But those are an indication of some of the results on my farm. Purple's bad, deep purple's very bad, and blue's not quite so bad. So let's skip over that one. So I diagnosed the problem. I realised that we had a lock-up effectively, and we started looking then at leaf analyses. But it was in the soil in excess, but it wasn't in my plant. So, how can that be? It's because it's all locked up. It's not available, and we have to find ways of making it available. So it's a real conundrum. But then I started doing sap analysis. It's very mobile within the plant, so you've got to test young and old leaves. So there's a hell of a lot involved with dealing with phosphorus. So I deprived it then of poultry muck on my farm. I stopped using it in about 2010. My dad thought I was mad. Stopped using granular fertilizer and reduced the amount of chemicals we're using. We did get an impact on yield, but my input costs reduced, believe it or not. But we were arresting the soil, and this is very important. You've got to rest the soil to give it a chance to recover and to try and pick up on things. Then the next step of action really was to use foliar nutrients just to see us through until we could find a way to remediate the soil. The recovery phase, I started feeding my chickens phosphorus solubilizing enzymes, which meant there's less phosphorus in the manure, and that really helped the effect. We had the cascade effect. We put zeolite in the litter and stuff like that, and I started making a lot of compost. And then there's all the min-till, all the regenerative things you've spoken about. There is no silver bullet. You've got to do something to try and sort it out. Basically, get your pH right, get your water right. To get your water right, which is 25% of the soil, you need to get your organic matters in order. Organic matter, that also helps biology. Biology makes the soil porosity, which is the other 25% of your soil, which is the air. And sorry I'm rattling through this. I could talk all day about this, but my wife tells me off regularly. Right. I know. Well, it's your turn next. Extensify is the term I use. It doesn't mean anything, but it means my business is less intensive than it used to be. So, to try and tell you about what's happening in the Wye catchment, and I've warned you already, this might happen. There's a refocus report. This is done by Lancaster University. It's easier to start by explaining what it is. It's about the phosphorus efficiency throughout the food system. And one of the parts of their reports is about the Wye catchment. And the easiest bit to tell you is what's not in this. Diffuse point source pollution from the water board, storm overflow, 4,200 events a year. Right, okay. But the other thing that's not in it is anaerobic digestion. I have got a neighbour with an AD plant over there, so irresponsible anaerobic digestion, would you say? No, AD, you do have to make sure that you responsibly use anaerobic digestion, the digestate or liquid digestate, the same as you do poultry litter. And also, I know that Richard grows maize with undersown grass. That means you've not got bare soils in the winter, which is very important, or fodder beet, which is something that we do suffer. And I'll show you a land use chart change of Herefordshire just now. Loads of acronym alert, but the most significant thing here is the Dutch rule in 2018, which meant that the levels of phosphorus measured in the River Wye fell below the target, and the River Lug particularly. Loads of other things you can see that we're suffering from. Don't ask me those acronyms, I've forgotten already. This is a picture of the River Wye. You can see an algal bloom there. This is what you see sometimes in the summer. But the question mark, is it phosphorus or is it nitrates? Is it flooding or is it the temperature, or is it all four? Or does it matter what it is? We can see the river in that state. We need to do something about it. The ranunculus weeds have suddenly started to disappear. They've reappeared this year, but who knew that farmers wanted to see weeds in Herefordshire? But we're getting around to that way of thinking. Other problems with economic impacts. We've got a planning moratorium. We can't build any new buildings in North Herefordshire at all. This is a chart showing agriculture from the report is 65 to 75% responsible for this. And what we think was we need a bit more enforcement from the Environment Agency. I don't know if there's anyone from the Environment Agency here. But when you see fields like this, and this is a river in my village, 2 hours rain on a Saturday morning. Above it, there's a weir with a mill stream that runs alongside the river. The mill stream was running clear, but we had 3 fields between me and the weir on that picture, and that's what you've got. That had digestate spread on it, had maize the previous year, and so maize in that instance. But it is a massive problem when you get water washing into the river. Remember, it's going to take all the phosphorus with it. So in Herefordshire, our logo is the bull. What the refocus reports tells us now is we're producing more chicken muck than we are cattle muck. So we're no longer talking bullshit in Herefordshire. We're now talking chicken poop. So that's because there's in the catchment there's 19.4 million chickens, and Ware, who one of the integrators, who are again not mentioned in the report, have got about 1,500 tons of manure. 150,000, sorry. Yeah, 150,000 tons. Yeah, shed loads of manure, right? And it needs moving. So what that amounts to in terms of phosphorus is 3,000 tons of phosphorus per year in the catchment. Now, can you imagine? That's done by the refocus team and the whole thing. And this is just for the River Wye, where targets are lower than a lot of rivers. You know, the River Severn, in fact, since 2000, the amount of phosphorus in the River Wye is reduced, not increased. But the target's reduced, so we need to do something about it. So on my own model, we then looked at deprivation. So one way we could do that is to export manure. This is a trial we did, which Richard's going to speak about later. But if you think that's chicken muck, and that's a bale of chicken muck. Oh, soil improver, is it, Rich? Yeah. 2 buckets of that make 1 bale. And I won't cover too much ground there, but I approached these guys, and they've helped us with some trials on that. So we can export the problem in the short term to try and find solutions longer term to these issues. But what it's really important to me is there's a call to action. There's something called the Wye Catchment Partnership, and it involves all agencies, the councils, the Environment Agency, the water people, the farmers, the citizen scientists. We're all in a room together, and we're trying to resolve issues which are perhaps modern agricultural issues. If I show you land use of Herefordshire, this was supposed to be on the slides but it didn't come out. That's 2016, and that's 2020. So you can see a lot more red on there. The red is arable, and the green is pasture. So we've got a lot less pasture in Herefordshire and stuff. So there's an awful lot of issues that are to resolve, but we can revert perhaps back to some of the old practices there. The other thing we need to do is, well, you've had 2 days off it, so I won't dwell on this, but to get rid of the legacy P, legacy phosphorus, we need to regeneratively farm. And 14 farmers, that is, have applied with the YNS Foundation for a landscape recovery scheme. And that's very much stream by stream, catchment by catchment, tributary by tributary, building it up. Small groups, hopefully, in the future working together. But we've got a 2-year pilot with 14 farmers first. Phosphorus stripping is something that can happen at the AD plants if we move the chicken manure there. But if we don't, it's just kicking a can down the road. The phosphorus remains right the way through the system. So we'll have to do that in the longer term. So this is the end of my bit. But really, it's a great opportunity for us in Herefordshire. I think the guys from Herefordshire here would agree, to galvanise, to sort this issue out, to really get on top of some of these issues and work with people and agencies to overcome it. So thanks for your time, and give these guys an easy time, please.
Yeah, Stephen did rattle through that rather quickly. One of the things that he didn't say was that he's very keen to do this as a group thing. And he didn't perhaps emphasise that enough. But the other issue which Stephen raised with us very early on was the fact that if something isn't done about this soon, then instead of farmers getting money for it at the gate, they're going to have to pay for it to be removed at the gate, because somebody will do something centrally and force the farmers to actually take it to or sell it to somebody to process for them. And that will cost farmers money instead of gaining them money. So we started looking at this with Stephen, and Stephen was very keen on the anaerobic fermentation route. And I have to admit, I was fairly skeptical about that as a process initially. We brew microbes, and those microbes are largely facultative. That means they can work aerobically or anaerobically. And those microbes can break down composts and manures and turn all sorts of bad stuff into good stuff. And I knew that we could compost with microbes. I wasn't sure whether we could anaerobically ferment in the way that Stephen was looking to do. So we started to do some work. Do I just press that one? Yeah. So these are the trials that we started back in the early part of this year. Stephen had already approached Orkle for their baler and doing a trial with their baler. And it's a particular baler that works for fine material like chicken litter. Most balers wouldn't be able to handle it, but this has a special chamber which allows the chicken litter to go into a special chamber which then can be baled properly. And we sprayed Microbz, a microbial solution, onto the vertical conveyor going into the baler, and we also subsequently put Microbz in through an injection system to get a little bit more volume into the bales. It was very dry. It's pullet litter, which means there was about 20% liquid in there, which is less than we'd like as people who want microbes to move around in solids. As I say, we did trials with various levels of liquid in there, various levels of dry matter, to see what gave us the best results. So this is what they look like as they're coming off the machine, and then the various issues that came out of this. These are the bales after they've been finished off. So it's anaerobic fermentation, and the key thing for that, which I've really sort of grown to love now, and I'm a messiah of this. I tell everyone that this is the way to go. Aerobic fermentation loses carbon, loses energy. That's why the compost piles at home reduce in size, because you're losing all that carbon. And we want that carbon and we want that energy for the future. This morning I went out and saw the Cherries windrow at 5 a.m, where they've been doing the trials on their aerobic composting, and they were steaming in the morning cool air. And that's everything going up into the atmosphere. We're losing all of the good stuff from the product. So it's crucial that you get nitrate production is very negligible in anaerobic conditions. Any ammonia that is in there, and chicken litter is full of ammonia, will stay as ammonia rather than being turned into nitrate, because there's no oxygen to turn it into nitrates. So it's really a crucial part of this. And what the great thing about our microbes is that they are facultative, as I said, and that means once the bale is opened and they're open to air, then you'll get a release of the activity as aerobic, and that will help to go into the soil and start to incorporate things. So all the nutrients are conserved, and I'll show you some test results to prove that. And the bales are clean, they're easy to store, easy transport, and biosecure. So it's a really good model for moving the phosphate problem away from the farm. So these are the results that we've got. We use land crop, and before I start going through this, I must say this is just an on-farm trial. We didn't take 100 samples of manure like you recommended to do. There just wasn't enough time or enough money to do that. So this is very much an on-farm trial with Stephen and ourselves trying to make something work and see whether we can improve the situation. So this looks at the pH values. Now the pH is critical, because if you can get manures down to a pH of less than 6.5, then you lock in ammonia, and that's the crucial figure. So chicken litter is notoriously high, and you can see figures there of 7.3, 7.2, so starting to go alkaline. We've had some figures later for field heaps. The chicken manure is typically left outside because it's too hot to use straight out of the shed. So farmers tend to put it in a field in the middle of the farm where nobody's going to find it, leave it for 4 months to let all of the noxious stuff disappear. And in the meantime, you also lose all of the ammonia, or most of it. But the pHs there can be in the 8s and the 9s, so very, very alkaline. But we're in the areas where we've baled with added microbes and baled, we found that we were able to get the pH of the microbe solutions down below 6.5. So we're locking in the ammonia at that point. So baling with and without microbes definitely improved or reduced the volatilization of ammonia. You can see the figures of total nitrogen given to us by land crop. As it comes out of the shed, it's 43.9 kilos of nitrogen per ton of chicken manure, and that's dropped down by the time it's been stored for 3 months in an open area, so not as a normal field heap would be, but in a covered area, that's dropped down by about 10%, perhaps a bit more, 15%, 37.6 tons. 37.6 kilograms per ton. Now, the field heap results have just come through from land crop, and that's down to 12.7 kilos. So you've lost 70% of your ammonia. Now, that on these sort of numbers, that's equivalent at the moment with fertilizer prices they are of about £60 per ton. So £60 per ton of manure. That's the nutrient value that we've lost in that ammonia volatilizing into the air. So based on the ammonium nitrate prices currently, £700 a tonne, which is roughly £2 a kilo of nitrogen when you take out the ratios, then we're looking at something like between £12.40 and £12.40, and if you take the field heap, that's nearer £70 per tonne of manure. So we're losing that amount of nitrogen, and that's money that the farmer could have. Rather than buying in nitrogen fertilizer, they could actually have that for free. And compared to a field heap, as I say, it's a lot more significant. And the 30% nitrogen that I put in the estimates from research actually came out as a genuine result. If you add in the phosphorus and potassium value of this manure that we've got, then you end up with £41.86 per tonne is the value of the phosphorus. And then the potassium is worth £30.10. We are being helped here by the prices as they are currently, but I don't think any of us believe that the prices are going to suddenly plummet. They didn't the last time they spiked, and I'm sure they're not going to go plummeting down again. But you can see there that the nitrogen value from the previous page, we've taken the conservative figure from a stored covered area. That gives you a nutrient value of £84 per tonne by putting them in the bale. So basically we've got a soil conditioner that's worth a nutrient value of £84 per tonne, just in those terms. And I'll give you some references there which you can look up with the HDB and things like that. The other really crucial thing is that there is this cleanliness, and Stephen took these pictures afterwards showing some bales that we'd stored in a field. There's no leakage, there's nothing happening to them. You can see the bales are still as they are. There's been no shrinkage, because it's anaerobic. Next door, he's got some open old silage clamps, and you can see there this pool of Guinness, as he calls it, which is because of the runoff and the leaching from the chicken manure that's left there. So in a normal situation, that's leached into the field and is now providing phosphorus that we don't need into the river courses. And then the other really important thing about this is because we've put the microbes into the chicken manure, it makes it really easy to incorporate. And that's the crucial thing. RB209, the AHDB fertilizer manual, specifies that you should incorporate within 1 day. Now, because of the microbes attract earthworms. They love microbes as a food source and as a way of eating their and digesting their food. And they will actually come and find the chicken manure. So this is an analysis side by side of a wormery where we put the equivalent of 63 tons per hectare, which is a massive amount, but it's such a small area that you can't see 8 tons per hectare equivalent on that size. And within 3 days, we'd incorporated the equivalent of 63 tons per hectare of this stuff. So it's really easy to get into the soil. It's moist. I don't know if any of you have seen field heaps, but they tend to be slightly burnt, slightly dry on the outside, and then there's this sort of soggy red-brown liquid all around them. And it's very, very difficult to incorporate that into the soil, and you've lost all of the nitrogen anyway. So there's some references that just show that we're not talking rubbish. This is backed up by some research as well. So Jeff is now going to talk a little bit more generally about microbes and what they do for us. We've still got some more work to do on the trials with Stephen and seeing the nutrient value, but there are a lot of people looking at this issue, and there are lots of ways that this material can be used. Today, for example, we've just been talking to CCM Technologies, who are interested in taking these bales and using them to produce pellets of fertilizer in the future, because they've got all the nutrients and they can be used as a buffer stock they're not going to go off. They're not going to lose any of the nutrients. So it's a really great way of moving forward with a valuable soil conditioner. Thank you very much.
So, thank you. So, someone held up a sign saying 5 minutes, so I'm going to try and rattle this off faster than Stephen. I was born on a farm in Kenya, and that's me as a kid, so I know a little bit of my background, so that's enough of the personal stuff. So, we're going to talk about microbes. I learned about microbes mainly on the continent. These are people there. They're well used in Germany, in Spain, in Austria, and so that's where I learned about them. They've been around for 4.5 billion years, so they're at this end and we're at the other end. And Stephen mentioned that before. So they've been around here for a long time. So basically, that's where life came from. The planet 4.5 billion years ago was covered by a mantle of microbes. And that mantle is still there in many ways. So when we go out and collect microbes, we believe we're going back to the original source of those microbes. So the first thing, what microbes do. Microbes, there's called a principle of dominance here. And this is true for your gut as well as for your soil. About 0.5% of microbes are pathogenic. 0.5 of microbes are effective microbes. They enhance things. And the ones in the middle are opportunistic. So they go to whichever one is the largest. So with microbes, all you have to do to have healthy, resilient, good immunity is to keep the effective microbes in the majority. So you're not trying to kill pathogens, you just apply enough so all your microbes work for you. The other thing they do is they change putrefaction or composting, where you're losing a lot of the carbon and sometimes creating toxins. You change the process to fermentation. The magic's in the fermentation. As soon as you put effective microbes into anything, into the soil, into your chicken litter, whatever it is, if you get the right amount in there, you change the process to fermentation. First thing that happens, the smell goes. If you apply microbes to slurry, and then you'll know you have enough in there when the slurry no longer smells. Now you've changed the process from putrefaction to fermentation. This is a picture of a friend of ours. This is a windrow in Spain of council waste, and also a small amount of protein waste and other forms of waste, and that's the size they can put them in. When you compost with microbes, you don't need to turn it as often, and you get a temperature control, and you can do it in very large sizes. So what microbes are good at is to close the cycle of life. So it doesn't matter where in your farm or wherever your garden you introduce them, they will help close the cycle. So you don't have to just put them in one place and they work. You put them anywhere and they work. Where we're not good at closing the cycle, microbes are very good at closing cycles. So where do we get microbes from? We just go and find a virgin piece of ground, and then we harvest the microbes from there. We collect them. Oh, that's nice. We collect the microbes, so all you don't need a laboratory, you don't need anything else, you just need a clean piece of land, and then you can harvest the microbes. This shows the species of microbes of the main numbers one. These are 14 of the most prevalent microbes that you get out of the soil. So obviously the Bacillus subtilis, which is one of Richard's favorite ones because it, fixes nitrogen and solubilizes other minerals. So that's the most prevalent. Then you have the lactillus ones, which we all know about, which break things down. That's an example of collecting microbes from 2 different locations in 2 different places, and you'll notice how they're almost identical. And that would also be true if you went to Germany or China and dug a hole and collected the microbes. You would get the same combination in the same quantity. So that's the sort of magic of microbes. So this is one of your slides, mate. Oh, you want me to sit here? Yeah, there you go. You step up there.
Okay. This is just sort of giving some of the benefits of putting microbes in, and perhaps explaining how they actually operate in the soil. Without chemical inputs, plants, you can put cover crops in, and you can go through all the regen processes, and they'll take time to get going. Because the communication's been lost. It's a bit like a drug taker who's been taking drugs for 20 years and they've lost the ability to generate dopamine themselves. So the only way they can get happy is to have another dose of drugs, or in plants' case, nitrogen. And by having a vibrant community of lots and lots of different species of bacteria. I mean, Jeff put up that slide, which has got 15 species of microbes on there. And they're all useful. They all do things in soil, but there's probably another 10,000 or maybe even 20,000 microbes species in there, and they're all useful for doing different things in different climates and in different environments. If a different pest attacks, and they'll all respond to the plant exudates coming out of the plants, and those sugars are sent down to communicate with the rhizosphere and access nutrients. The communication goes both ways, so that plants are told when pests and diseases are around, and they'll increase the cell walls thickness, or they'll close the stomata on the leaves, depending on what the microbes are telling them. So by having this wide variety of vibrant microbes, you will end up with the ability for the plant to respond to a whole range of situations. Also, microbes and fungi and earthworms, they all produce glues. And so having, again, this sort of wide range of things, that's where you get your soil aggregates from. Once you've got your soil aggregates, then the microbial solutions are actually they're helping to regenerate the aggregates, because they die off every couple of minutes. We've only got 2 minutes of questions, so I better speed up. But basically, the biodiversity above ground, we all understand, but you also need biodiversity below the ground as well, because those are the things that can really help to respond to nature's pathogens and all the things that can go wrong, and provide a resilient plant in a resilient soil.
Yes, compaction. We won't talk about that too much. Everyone knows about compaction. We contend that you get compaction not because you're driving heavy vehicles over it necessarily. You get compaction because there's no longer biology in the soil. And of course, the microbes do put the biology back in there. So these are microbes in soil. They help the structure. They find nutrients. They lock up carbon, and they create resilience. I think I've got about 30 seconds to go. One of the things that we reckon is by using microbes, we shorten the time of making the transition from traditional farming to regen farming. And I know we often hear farmers saying, it's 5-10 years of loss of yield. We believe that the microbes can reduce that time period significantly. Thank you. That's us.
Sorry, I know we've overstepped the mark, but Humphrey, my beautiful assistant there, has a couple of bags of manure. So if you're feeling masochistic, one of them has been treated with microbes, the other one hasn't. And Humphrey will stand here and open the bags for you, and you can smell the shit.
Yes.
Yeah, we've run out of time, but if anyone wants to ask me any questions, we'll be hanging around afterwards for a few miles. So thank you very much.
And thank you. See you next year.